Hello and welcome to Math for Today. We're going to be continuing on with what we did yesterday, which was understanding a bit more about line graphs, either where we have the points connected, which is a true line graph, or creating a scatter plot. And do you remember the type of data that we would use for each of those? Like what was it called when we have the lines connected? What type of data is that? It is continuous data. And then when we have the points that are not connected as a scatter plot, what type of data is that? That is called discrete. Okay, I really hope you can lock those two things in your brain. That was really important from yesterday. So today we're going to be creating line graphs. So it's a little bit just a further extension from what we did yesterday. Okay, so the I can statement is the same. So you don't need to write it in again. Right, because I can create, label, and interpret line graphs to draw conclusions. So mainly yesterday we were determining what we would do to create. That was kind of like step one, and a little bit of interpretation as well. Today we're focusing on the creation and the labeling. Okay, so title is creating line graphs. All right, there are 6 things you have to do for a graph. When you do this, so basically your graphs are going to be worth 6 marks, and yeah, that's how I'm going to be marking them. So this is what the criteria is. The first thing is you have to have a title with full information about the graph. So it should be something more than just 2 words, as you saw yesterday in our example. So it has to be a little bit more descriptive rather than just height of plant. Okay, growth of a plant over a year type thing. Should say something about the duration of time that you have measured this information. Okay, next thing is labeling the x-axis with correct values. So the x-axis is of course the one that goes across the bottom. So labeling would be, for example, day of the week. Okay, that's the label. Then you also have to have the correct values. So then you would have something like Sunday, Monday, Tuesday, Wednesday, Thursday. Okay, or maybe it's something different like distance from home if you're biking or something. So be distance from home would be the label. Then the correct values would be 10 kilometers, 20 kilometers, 30 kilometers. Okay, so technically they're both worth half a mark. If you put in the values like Sunday, Monday, Tuesday, Wednesday, then you don't say days of the week, then that would take off half a mark. Okay, so you have to put in both of those things. Next is, okay, you probably guessed this, labeling of the y-axis, which is the exact same, but going vertically. The only side note to this, and which also could actually potentially be for the x-axis as well, depends on what your data is that you're talking about. But you need to put the unit of measurement in brackets so that you do not have to be redundant with writing milliliters, beside every single time that you plot up the y-axis. If you put it in brackets once, done deal, way easier. Remember, mathematicians are lazy. It's much easier that way. Okay, the next thing is you have to have an appropriate scale. So that means that you're not jamming all the values into a little tiny corner, or it's not ginormously spread out. So to pick a scale, what are you skip counting by that's appropriate. Also, it might be together with the appropriateness of putting in that little slinky thing. Remember where we do it's called a break in the line graph, where, say, for example, your values don't start until the ones we did yesterday started at 40. Well, we're not going to show a wasted space of 0 to 40 and then tons of stuff between 40 and 60, for example. Then it would be appropriate to choose a break or a little slinky thing in your line graph in the scale. The next thing is consistent. So it has to skip count by the same value all the time. You can't go skip counting by 2s for a bit, then skip counting by 1s, and then skip counting by 5s. It has to be the same amount that you're skip counting by each time, which I think kind of goes without saying, but still, if you do that, it's not accurate. Okay, next thing is you have to use the correct plotting or connected data. So that means that you accurately determined whether the information is discrete, which means that you would do just the plotting of the data, or if it's continuous, in that case, then you would connect the data points so that it's a true line graph. Okay, so that determination, basically this is what we learned and when we practiced yesterday. Okay, next. And last thing is you have to accurately transfer the data, which is kind of a freebie, really, because it's just can you plot the right information on the graph? So it's it's just, it's just knowing that, okay, Sunday's value was 5. You're not going to put Sunday's value at 7. Okay, so it's kind of easy, but anyway, worth a mark. Okay, so that's it. We're going to practice one today. So creating line graphs. All right, so I just added this one. Water consumed from the water cooler. Okay, and we're gonna check this at a couple different points throughout the day. Maybe this is at your house. Okay, so let's say amount of water, milliliters. Okay, so amount consumed. So maybe, for example, it's starting like full, for example, and then we're checking what level it gets to. So say, for example, it's at, I don't know, let's just say like 1,000 milliliters. Okay, and then we check at 6 a.m. Let's say we start at 1,000 milliliters. Like, oh yeah. Then maybe we go down, maybe at 10 o'clock, everyone was really thirsty because it was the morning, and now we're down to 800 milliliters. And at 2 p.m., we had lunch over there and like a snack. So now we're down, we drank a lot. Now we're down to 500 milliliters. This is maybe for a big family. Then, actually that's not really that much. Sorry, this could be maybe from like a water bottle. Because 1,000 milliliters is just a liter. Water bottle. Sorry, I'm gonna change this. Okay. Then at 6 p.m., we didn't really have very much. Maybe we're down to, I don't know, 350 milliliters. And then at 10 p.m., we have only 100 milliliters left. Okay? Amount of water, let's see, left. There we go. Okay, nice. Okay, super, super, super. So now what we need to do is all of the things which we had from earlier. So the first thing is you have to have a title. So usually what you can do is just copy this and then paste, okay? Because it's usually going to be the exact same thing, okay? Then I need to label my axes, right? So this one is going to be day of the week. Oh no, time of day, sorry. Time of day. And then, whoops. Back, I did not mean to do that. There we go. Okay. And then, whoa. Okay, and then I'm gonna move this over here. Okay, and this is going to be amount of water left. Okay, and again, I'm putting my units in milliliters. Okay, now I need to draw. Okay, so this is going to be 0. Okay, and then my highest value is 1,000. So let's see. 100, 200, 300, 400, 5, 6, 7, 8. Oh, geez, that was perfect. Okay, so 1,000. Okay, and then I'm just going to save a little bit of time here. So this is going to be 800. And I'm not going to write in all of them. 600. And then this would be 400. And then this would be 200. There we go. Okay. So messy. And then time of day. Let's see. Could this one maybe be 6? And then 10. And then 2. And then 6. And then 10. Yeah, that works. Right on. Okay. So 6 a.m. 10 a.m. 2 p.m. Right? And then 10 p.m. Okay, I should write in all of them too, but I'm just not going to for this moment. Okay, water consumed from the water bottle. Okay, so now, right on. So let's just see this. I've done my title, I've done my labeling, consistent scale, check. Now I have to just correctly plot the data. So 6 a.m. had 1,000. Then let's see, 10 a.m., which was right here, had 800. 2 p.m., well, we had a big drop to 500. And then 6 p.m., we were at 350. So here is 3, and then 50 was right here. Then we had another big drop here. Oh, I guess this is kind of a straight line. Huh. Okay, now I'm gonna connect my points. This is so messy of mine. Okay, because it doesn't mean, because I can have half a milliliter, right? Like, doesn't mean I didn't take data between these hours, but I could have, and then I could have noticed that there was a drop. So probably we didn't only drink exactly at these minutes. We would have drinking water between as the times as well. Okay, so that is that. All right, your homework today is the workbook, pages 94, 95, all of the questions, including stretch your thinking, which is this. Okay, so they give you a nice example. Draw this in. They already did the title and the labeling, right? You just have to plot the data and decide if you're going to connect it or not. Pretty easy. And then this one you need to do, okay? And then I also want you to do the stretch your thinking, okay? I would like you to take a picture, please, of this graph as zoomed in as possible, just on the graph for me to see, and then put it onto Edmodo, please, okay? Or sorry, onto Seesaw. So I'm gonna write that. Yeah, okay, anyway, you know it. I'll put it in Seesaw, okay? So this graph of like 1A on page 95 needs to be on the graph. Okay, that's it, good job.